Alright, now we're going to be doing the HSC paper of 1998. We're going to be focusing on question 7a this time. So this is a binomials question. So it says, use the binomial theorem to obtain an expression for 1 plus x to the power of 2n plus 1 minus x to the power of 2n, where n is an integer. And then the second part asks us to hence evaluate 1 plus 20c2 plus 20c4 plus all the way up to 20c20. Alright, so how we're going to begin this question is because it says use the binomial theorem, we're going to straight away expand our top thing here. So the first bracket, so we'll take down I to here, we're going to expand 1 plus x to the power of 2n. So as we know, this begins by we have our single constant term, so it's got 2n and then have 0 here, and x to the power of 0 is obviously 1, so we don't have to have an x here. The next part of that bracket is now our first term, so 2n c1 plus x to the power of 1, so it's x. And we can continue this process all the way up to 2n c2n and x to the 2n. Alright, so that's our first bit done. That's the first bracket here. So to indicate that, I'm going to have a square bracket to show it's all closed off. And now we're going to begin by expanding now the second bracket with our binomial theorem expansion. So we've got 2n c0 again. Now because we have a negative here now, so our next term will be plus 1 2n c1 minus 1 to the power of 1, which is minus 1. So I can rub that out and have a minus there instead. And x to the power of 1 is again 1, x, sorry. Now plus 2n c2. Now minus 1 squared is obviously plus 1, so we have a plus here. And our next thing is x squared. And what you'll notice is that every odd term is in fact negative, where every positive term is positive. So we will have a negative for the next one, and then that will go on till finally we have our plus 2n to the power, and then 2n, and 2n c2n minus 1 to the power of 2n, and x to the power of 2n. Now what do you notice about this minus 1 to the 2n? Well, if n is an integer, it's always going to be a multiple of 2. So that means it is an even number, and we all know that minus 1 to the power of any even number is in fact a positive number. So we can forget about this minus 1 to the power of 2n because it's always going to be positive 1. So what that leaves us with for our final term is actually x to the 2n, and that's pretty much it. Okay, so we've done our binomial expansion now. So all we have to do is now consider that there is in fact like terms on both sides. See, we've got a plus 2n c1x, and we've also got a minus 2n c1x. So those two would cancel. And if we take it up to the 2n c3, it would have a 2n c3 x cubed here and a minus 2n c3 x cubed here. So what we've learned is actually that the odd terms will in fact cancel each other out to 0, and we'll have duplicates of all the even terms. So when we add all this together, we're left with 2 lots of 2n c0 plus our second term, so 2n c2 x squared plus dot dot dot, and it's all the way up to the even terms, and then we have our final term of 2n to c2n x to the 2n, since we know that 2n is going to be an even number regardless of what n is. And that's the first part of the question done. So what we've learnt is that this expanded with our binomial theorem is in fact 2 times the sum of all the even terms. Alright. So now we're going to be focusing on part I now, part double I. So I'll leave it down here because we'll notice that this is actually a short one. So hence evaluate 1 plus 20c2 all the way up to 20c20. Now, if we're going to use part 1 because it says hence, we'll try and see that, notice that there's 20 in the c's, the combination, and also that we have 2n here. So we want 2n to be identical to 20. So how are we going to do that? Well, what if n equals 10? 2 times 10 is obviously 20. So what we're going to start off with is let n equals 10. Because now from in part I, this will convert our thing to 20C0 plus 20C2 plus all the way up to, and now 20C20. So, oh, sorry, there was meant to be an x squared here because you haven't taken the x's out yet. So we're left with 20C20 x to the 20. And what we also learned from part I is that this is also equal or equivalent to our 1 plus x to the 20 plus 1 minus x to the 20. Now I'm just checking if that's in the screen. Yes, it is. I'll step out. So what we've learned is that 2 times 20c0 plus 20c2 x squared all the way up to this term is equal to 1 plus x to the 20 plus 1 minus x to the 20. Okay, so we're almost there. So because there's no x's in this, I believe that we have to substitute x equals 1 because these are all positive terms and there is no x there. So next step will be to let x be equal to 1. So now that will leave us with 2 times 20c0 plus 20c2 plus dot 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 plus 20c20. And on the right hand side, that's equivalent now when x is equal to 1, we've got now 2 to the power of 20. And then when x is equal to 1 and 1 minus x, that's actually 0. So it's just 2 to the power of 20. All right, and the last step, since now we've got a times 2 here, we'll divide everything by 2. So what we're left with, so when we take away, we divide by 2, we'll have 20 to the power of 19, 19 instead. So what we have finally found, so I'll bring it all the way up to here, that we have found that 20c0 plus 20c2 plus 20c20 is actually equal to 2 to the power of 19. And that's how you finish that question.